Welcome to Train Signal. You are watching Configuring SAN Connectivity. This lesson is the other side of the coin of the networking lesson that we just did. And usually when we're doing a deployment, there are kind of some big major milestones of deploying UCS. There's getting the gear up and cabled. There's networking configuration, storage connectivity configuration, and then blade configuration with service profile. So this is the next big step. And this is a fairly long lesson with a good lab at the end. But it's an important lesson, and really depending on the type of storage you use, it can be very fundamental to the deployment of your UCS environment. We're going to start with Cisco UCS and storage connectivity. Here we'll go over some generalities, types of storage supported by UCS, and answer some common questions. Next, benefits of Iscsi and Fibre channel. With the stateless nature of UCS being able to move workloads from one blade to another, there are some requirements placed on storage, and we'll talk about why things like Iscsi or Fibre channel are a good idea. If you're not familiar with Fibre channel, I'll give you a primer on Fibre channel, which is important. If you're working with a storage team, I want you to be able to have a good, intelligent conversation and know what to ask them for. And if you're going to sit the DCUCI exam, Fibre channel connectivity is absolutely within the blueprint. After that, it's how UCS integrates with the Fibre channel fabric. So these talk about some of the requirements, what we need from the fabric, how things are configured, and what your options are as far as switching modes and things like that. Then, connecting SAN ports, which is just the type of ports and how we configure them. A little bit about virtual storage area networks, or Vsans, which are very familiar to VLANs on the network side. I'll give you an overview of Fibre channel over Ethernet, or FCOE, which is used internally between the interconnects and the chassis, but is becoming more commonplace in the data center. Then a little bit on virtual host bus adapters, which are just like kind of the VNICs or virtual network interface cards from the networking lesson, where we can take some of the ports on the mezzanines and slice and dice them up, or just do one-to-one mappings with the Hbas on the card. But it talks about, the configuration of those. Then finally, what I call other storage ports, or some new options with new versions of UCS. So with all that, let's go ahead and get started. With UCS, you can pretty much use any type of storage you want. So there's local storage, which are the disks on the blades. There's Fibre channel, Iscsi, NFS. With some of the newer versions of UCSM, we can now do Fibre channel over Ethernet, which is Fibre channel, but it's a slightly different variant and encapsulation. Depending on what you're doing, Fibre channel requires some configuration. If you're booting from Iscsi or via Iscsi, that requires some configuration. But local boot doesn't really require anything. We set that up in the service profile, and we'll talk about that later. But no real configuration on the interconnects. NFS, you can't boot from NFS, but if you're running VMware on a blade and it connects to data stores over NFS, there's again no configuration really needed. But with Fibre channel, you've got to do some configuration because you have to connect the interconnects into what we call the Fibre channel fabric, and it's a lot like configuring the networking and uplink configuration to the core switches. And you'll see that as we go through here. It's different, but the ideas are very, very similar. And first I want to talk about the benefits of Iscsi and Fibre channel. So UCS has a concept of service profiles, and it's a term I've kind of tossed about here and there. But the idea is that you don't install really an operating system directly onto a blade and use all the blade's hardware addresses and settings and things like that. We do it based on a service profile. And a service profile is a container. It containerizes things like MAC addresses and UUIDs and firmware versions and BIOS settings and all these things that make a server a server. And we go into these very deep in a service profile lesson. But I want you to know why these are important. If we want to take an installed version of Windows on one blade, shut it down, move it to another blade, and boot it up, we can do that very easily with service profiles. But to do that, we need to boot from some central storage. And normally we do what's called boot from SAN with Fibre channel. We can also now, with the new versions of UCSM, boot from SAN via Iscsi. But the idea is that to move that service profile from one blade to another, I have to boot centrally. I can't be on one blade and boot that if the operating system is physically installed on hard drives inside of another blade. That's why the vast majority of our UCS implementations are diskless. There's no disks in the blades. Everything comes from a central SAN. The reason that we have to say Iscsi or Fibre channel is that these are block level protocols, and you can't boot from a kind of file-based protocol. You can't boot from NFS, it's not supported, so we have to boot from Fibre Channel or Iscsi. And if you want to use that stateless functionality, then you want to do this. Now, you can boot from Fibre Channel, say boot VMware from Fibre Channel and use NFS data stores, or boot a Windows server from Fibre Channel and then use Iscsi to connect to an Iscsi target. You don't have to pick one and stick with it. You can mix and match as you need. Let's talk about Fibre Channel. So Fibre Channel is very popular. It's a mature storage protocol, and it operates at 1, 2, 4, 8 gigabit, and then there's new 16 gigabit speeds as well that just kind of started really entering the market. It's again a block level protocol. If you're not familiar with that term, what we mean is that the hard drive in a workstation, that workstation is or the operating system running on it has block level access to the disk, meaning it can format it, write it, destroy it, do whatever it wants. It owns that disk and has full access to it. It has block level access. But if I connect over the network to, say, a Windows file share or an NFS export, that is file level access, or NAS, network attached storage. So to do anything, I have to ask the file server and make a request and get a response. I can't format that Windows share, that CIF share. Fibre Channel gives us block access to storage over a network, or what we call a Fibre Channel fabric. This way we can have a SAN, a storage area network, a large enclosure of disks, and use those and carve them up and have really high performance, but still give access to all the hosts around the data center. The other kind of alternative to this is Iscsi, which is another block level protocol. It works over IP, over normal 1 gig or 10 gig networks. Similar in functionality, different in the layer 1 in connectivity and configuration. When you're connecting a host via Fibre Channel, we use what are called Hbas, host bus adapters, and I've got a picture of one right there on the right. And you connect using, since it's Fibre Channel, we use fiber optic cables, and there's one right there on the bottom right. And this gives us very high speed over Fibre Channel, but also longer distances than we can do with copper, and that's why Fibre Channel has been very fast, very mature, very popular for a long time. It gives us the speed and distance that we need. Modern Fibre Channel fabrics or networks use switches, and there used to be like Fibre Channel loops and some other sorts of topologies, but now everything's based on switches, and they're very similar to switched Ethernet networks. We have two kind of classes of switches, if you want to say. We have the small work group switches. These are like 1U and 2U top of rack type switches. They're normally 16 port, 24, 32, 48 port size switches. Then we have the large director class switches, these big chassis switches like Cisco's MDS 9506s and 9509s and 9513s. Large chassis switches, very high speed, very high performance, very resilient. If you remember back to the Cisco kind of data center strategy very early on, we went over some of those and showed those to you. For the most part, UCS doesn't care which one you connect it to. It doesn't have a need or a requirement that really dictates you need to connect it to a director class switch. Majority of our implementations are against workgroup class switches. Cisco's 9124s, 9148s, those sorts of switches are very common, so it doesn't have a lot of requirements from the Fibre Channel fabric. Fibre Channel addressing is somewhat similar to Ethernet. We don't really use something like IP addresses. We use the it would be similar to what's a MAC address in the Ethernet world. Servers are normally known as initiators, so it's initiating a connection. Storage arrays are usually known as targets. So I'm an initiator, I connect to a storage array that is a target. To allow the two to communicate, you perform a process known as zoning. You may hear that term used a lot. You zone one or more initiators to one or more targets. The idea being that by default, if I drop a Fibre Channel switch in front of me and I plug a server into a port and I plug a storage array into a port, those two aren't allowed to communicate. We have to zone them or allow them to talk. We put them in a zone, therefore they can communicate. Think of it as an access list. And this is to keep, servers from accidentally overrunning storage that they shouldn't have access to. So if I have an Exchange database and I have a volume with that on it, I don't want my non-Exchange servers to be connecting to it. So I may restrict that, It may be on a storage array all by itself, so I want to restrict everyone else from communicating with the storage array except for my Exchange server. Just as an aside, when we do these things, there's really two phases to this. We do zoning, which is the connectivity between the two devices, but most storage arrays also support what's called LUN masking. Zoning doesn't help if I have one storage array and 20 blades or 20 servers connecting to it. I'm going to zone all those servers to connect to the storage array. If all 20 servers saw everything that storage array had to offer, it would kind of be defeating the purpose. So storage array is also what we do LUN masking, LUN, logical unit number. When I carve up some disk in a storage array and present it to a host, I'm presenting it a LUN. It's called a LUN or a volume, and it's given a number from 0 up to whatever your storage arrays really are supporting. But what we do is we mask out LUNs that a server shouldn't have access to. So while all 20 blades or 20 hosts may see that storage array, they're only going to see the LUNs that matter to them. So back to the Exchange server. The Exchange server sees a storage array. Inside the storage array, I unmask the LUNs for the Exchange databases. He sees them, but nobody else does. I may have 5 hosts in a VMware cluster. When I may have some data stores carved up, and all 5 of those hosts need to see those data stores. So all 5 hosts are zoned and allowed to talk to the array. And then on the array, I unmask those 5 LUNs holding the data stores for those 5 different servers. So you can mix and match and create the kind of secure and separation that you want to do. But that's the difference. We normally zone in a switch. We do LUN masking on the storage array. Now back to addressing from that little bit of a tangent. Addressing again is kind of like a MAC address. We have 2 different addresses. We have what's called a worldwide node name. It's a device or HBA address. And then we have a worldwide port name, which is specific for a port. So let's say I have a single HBA, host bus adapter, but it has 2 ports on it, which is very common. The host bus adapter will have a single worldwide node name. Looks very similar to that one there with the hex, kind of like a MAC address. But each port will have their own worldwide port name. So total, that card is going to have 3 addresses, one for the card, and then each port has their own. When we do zoning, we normally zone against the port name, not against the node name. Reasonings for that are, a big one is that unlike Ethernet fabrics where switches are cross-connected to each other through the whole fabric, with Fibre channel, we normally have a fabric A and a physically separate fabric B. Fabric A may be a single switch, it may be 10 switches. Fabric B may be a single switch or 10 switches, but they are normally not cross-connected at all. This is to keep containment and separation so that a problem in one fabric doesn't take down the entire storage network for both fabrics. Therefore, if I have a card with 2 ports, one port will go to fabric A, one port will go to fabric B, we zone against those port numbers and names, not against the HBA or node name. The WWNN and PN are hard-coded, just like a MAC address, but as we'll see, in a later lesson, we don't usually use those. We use some pools of addresses that we create, again, because if I want to move a workload from one blade to another, I can't zone against something physically on that original blade. I need something that's portable. But in the end, the addressing and the zoning is exactly the same. So by default, we're just kind of going back over what I said on my monologue there. Devices on a Fibre channel fabric are not allowed to communicate. Zoning is allowing that communication. So you zone and then you LUN mask. You zone initiators to targets using WWNNs and PNs. Normally we use port names. And the exact process depends on the make and model of your switches. So Brocade is going to be a different process than Cisco, which is different than McData. With MDS, which is what I use most of the time, you can use the command line interface or Fabric Manager GUI, or there's a new tool called Data Center Network Manager that'll probably supersede Fabric Manager, but you use what makes the most sense for you. Some of my engineers, they love Fabric Manager. Other engineers and me, we love the command line. But to do a lot of zoning, usually Fabric Manager is probably the easiest, though I do a lot with command line. We also can do some very interesting things. We can zone ahead of time. So I talked a little bit about having those pools of addresses. We normally create a pool of WWNNs and PNs ahead of time that we assign to the blades. Again, portable addressing. We'll talk about it in the pooling lesson. But we can go ahead and pre-zone things. If I know I've created a pool of 16 worldwide port names, and I'm going to zone those against that single storage array out there, we have scripts to go ahead and pre-zone these things. So it kind of makes it easy. We don't have to wait till a blade boots up and see what its node name is or port name. We can do it ahead of time. And we do that normally via the CLI. Details of zoning are kind of out of the scope of this course. It's not a fiber channel course, but it's important you understand these concepts, especially when talking to a network team during deployment. And I'm going to show you some examples of zoning at the lab at the end of the lesson. I just at least want you to see it and kind of get a better feel for how it's configured. Continuing the primer on fiber channel, I want to talk quickly about port types, and this leads us into some other slides in a minute talking about what the requirements are. Now, there's a few types of ports, and I've got a diagram here at the bottom. On the left, this is a server or a blade, some sort of a node. It's an initiator, let's say. On the right, I've got a storage array. We'll call this a target. Then I have two switches in the middle. And then I've got everything, kind of pointed out for your node, port types. So there's end ports. End ports are ports on an end node. It can be a server, it can be an array. It's just an end device. And so it doesn't really matter if it's an initiator or target, that's an end port. That port is the port physically on that device, kind of on the HBA. We then have E ports or expansion ports. Those are usually used to connect switches together. So as you grow your fabric and you need more ports, then you'll connect switches together, and those ports are known as E or expansion ports. Then there are F ports, F as in Frank, for fabric ports. Ports on a switch that connect to end ports are called F ports. So if I plug my server into a switch, the port I'm plugging in on the server is an end port. The port I'm plugging on the switch is an F or a fabric port. And there are some other ports, but these are the ones that we kind of need to worry about for UCS. Now, I don't go in and configure these usually as like an N port on a host or a F port on a switch. It denotes functionality, and normally switches will know if I connect two switches together, you can look at the interface and you'll see it flip to E port mode. When I connect in an end host, you'll see the switch port go to F port. But it's important to understand kind of what the functionality is. And really, I want you to understand the N ports and F ports because that's going to be important here in a second. Cisco uses a technology, Cisco UCS uses a technology known as N-Port ID Virtualization, NPIV. NPIV allows a single N port, remember it imports that port on a device, to have a bunch of initiators behind it, or WWP ends and WWN ends behind it. Now, does this sound familiar? Well, it should, because it's very similar to in-host mode in networking, where we connect it up, and to the up-level core distribution switches, the UCS interconnects look like a single host with a bunch of MAC addresses. Well, to the fiber channel fabric, the interconnects by default look like a host with a bunch of initiators behind it. Very similar. It requires a switch operating in NPIV mode, and this is just in-port virtualization, or in-port ID virtualization mode. And almost all fiber channel, even small little workgroup class switches, support NPIV mode. And though this is what you're going to need to request from the storage team, you're going to ask them to enable NPIV mode, which, like on most switches, is non-disruptive. You run a command and it says, okay, I'll now support that. The interconnects use NPV, in-port virtualization. And this is, I know this is confusing. It confuses me. I'll go and try to enable NPV on an MDS switch, and if you let it, it's not a good thing. So if you enable NPIV on a core or workgroup fiber channel switch, it just enables. If I say I want to enable NPV, it says I'm going to erase your config and reboot. Well, that's not what I want, not at all. So you just want to make sure you request the right thing, which is NPIV. And to simply put, it just lets the interconnects appear as FC host with a bunch of WWPNs behind it, just like in host mode for networking. In later versions of UCSM, the fabric interconnects have two modes. By default, we're in FC end host mode, very much like the end host mode on networking. But also like the networking side, we can enable this kind of limited functionality switching mode. So it turns around and makes it like a limited functionality MDS switch. It's not recommended. You're going to hear me repeat a lot of things I said on the networking side. There are scalability issues with this. It's only for small deployments. And the idea here was to enable this for small deployments where if I'm putting UCS into a smaller office and they're buying an array and they're buying UCS, and the idea being they don't really want to buy fiber channel switches because the only thing they're plugging into it is an array and UCS, right? Why can't I just plug them straight together? And that's what kind of brought this about. Now, as of the current versions of UCSM, like the initial versions of 2.0 and back, it's not recommended you use this. It was actually brought out, I believe it was 1.4 that enabled this, and then Cisco changed their mind and said, you know what, we really don't recommend you do this. We're having some scalability and performance problems. And there are ways to continue to use this, but what you normally have to do is introduce a fiber channel switch that does zoning, because when you enable switching mode, the interconnects don't do zoning. So it's what's called open zoning, meaning all initiators are allowed to talk to all targets, and it causes some problems. The idea was you could take a small fiber channel switch, plug it into the interconnect at a fiber channel port, and then that switch would handle all zoning. So you configure it there, even though nothing else was plugged into it, and it would push the zones down to the interconnects. Well, then I asked a simple question. If I have to introduce a small switch for zoning, why don't I just leave it in host mode and plug everything into the small switch? We haven't seen a lot of use for this. So getting back around to it, my high recommendation, at least for now, is to leave it in host mode. It's very, non-intrusive to do that. Similar to Ethernet, we can do fiber channel port channels and trunking. Port channels, just like Ethernet again, bind multiple links together. Better load distribution, and if you fail a connection or a link that's part of a port channel, nothing has to be repinned. So if you remember, we talked about network connections getting pinned to uplinks. Well, fiber channel connections from a blade also get pinned to uplinks to the fiber channel fabric. With port channels, if we lose a link and the port channel still has a surviving member, at least one, things just automatically happen and get redistributed. There's no repinning, and it's much faster. Downside to this is you have to have MDS or Nexus fiber channel switches from Cisco. Brocades and McDatas don't do this. So it's suggested, not doing a Cisco pitch, but some of these things do require MDS switches. Trunking is similar to Ethernet trunks, and we'll get to what a Vsan is later, but the long and short of it is that a Vsan is similar to a VLAN. I can carve up a fiber channel fabric into a bunch of kind of logical or virtual fabrics using Vsans. And so it used to be that a single connection, so I'd plug a cable into the interconnect and a cable into my fiber channel fabric, and I said, okay, you carry Vsan 100. And then I'd plug another cable in and up to the fiber channel switch. I'd say, okay, you carry Vsan 101. And so you couldn't run multiple Vsans over a single connection, cable, or port channel. Now you can. But when you enable it, all Vsans traverse all links. So it's kind of like it's either you're all in or you're all out. These were both introduced in UCSM. So I'm going to do a little bit of a tangent here, and I talk about this more in the later lesson where I'm discussing preparing for the DC UCI exam. Right now there's two exams as I'm doing this, and I'll talk about later. There's the current exam, and there's an exam coming in February of 2012. The problem is Cisco doesn't tell you what version of code they're testing you on. So if you're taking the one released in 2012 in February, I would assume it's based on a later version of UCSM. If you're taking it, before then, or take what's called the old exam, I believe it's good until like May of 2012. It's based on old, probably predates 1.4. So I don't, you may not get a question on this. I haven't seen any on this, but you might, and it's just kind of a guess as to what version they're testing you on. We can kind of infer that from when the exam was released, but that's why I try and tell you when things were introduced so you can make intelligent decisions, or at least try to figure out, where you need to answer. So connecting SAN ports is very easy. Again, it's very similar to networking. So I go over and I plug my cables in. Well, first, if you go back to the live lab that we showed you, I have to plug in a fiber channel SFP, this little small form factor, little pluggable module. On a 6100, the fiber channel ports are in the module slot on the right, and they're dedicated fiber channel. All they do is fiber channel, and they have the little green border around them. On a 6200 series, you can basically put a fiber channel SFP in any port. You have to configure the slider, and you basically draw a line on the 6200 series. Anything to the left is Ethernet, anything to the right is fiber channel, but anything on the right you can put an SFP in. So you do that. You connect your cable between that SFP and your fiber channel fabric, and the way you do this is that fabric interconnect A, you need to connect to, say, fiber channel fabric A, and fabric interconnect B goes over to fiber channel fabric B. So you do not cross connect those. You go one to A, one to B. You connect those, and then you go into UCS Manager, you right click the port, and you set it normally as an uplink port, which is the simple way to do it. You can also, when you do this, assign the appropriate Vsan to the port. Now, again, if you enable trunking, all connections carry all Vsans. But if you're not doing trunking, you just pick down which Vsan you're going to use. And we'll talk about Vsans again in a minute, but you create those like VLANs, and then we assign them to the uplinks. And finally, if you're going to use port channels, and I recommend you do, go ahead and add that in there. Similar to pinning for data, virtual HBA ports are pinned to fiber channel uplinks. So now a virtual HBA can be it can be about anything. So if you pick a 10 gig, the Intel 10 gig data only card, there's no HBAs. So you can't do fiber channel. So you're out of luck. But if you do, say, the CNA adapters from Emulex or QLogic, or CNA mezzanine adapters from Emulex or QLogic, they have 2 ports on them. Each port has an HBA. When we do service profiles, they're turned into virtual HBAs because, again, we virtualize those. If you're using a VIC card like the Palo or the 1280, we can slice and dice up a bunch of virtual HBAs. But in the end, HBAs are pinned to fiber channel uplinks. And an uplink can be, just like on networking, a single physical connection or a port channel with 4 connections in it. And I reiterate again, I suggest you use port channels. Faster failover and better load distribution. In fact, if for some reason you're only connecting one cable from fabric A, interconnect A to fiber channel fabric A, and one from B to B, even though I highly recommend you do more than one on each, at least 2, but I still suggest on the first one you go ahead and set up a port channel. Later, as you add more, you can roll them into the port channel and take advantage of it. Pinning is done automatically by default, again like the networking, but you can override it with a pin group. So if you want to specify these virtual HBAs go up these connections, we can do that with a pinning group. If uplinks carry only specific Vsans, then HBA ports are tied to those that carry the same Vsan. So let's say I've got 2 Vsans on each fabric, Vsan 101, 102, 201, and 202 on fabric B. When you create service profiles and virtual HBAs, you say this virtual HBA is tied to a VLAN. A virtual HBA cannot exist in more than one VLAN. So I'll say virtual HBA you assign to 102. Then it's going to automatically pin to that physical uplink that carries 102. It doesn't do any good to pin it to an uplink that carries a different Vsan. It's got to go to the same Vsan. If you set up a virtual HBA that's Vsan 202, it goes up the links that only carry 202. But again, if you're doing trunking, it can pretty much go up anything that supports carrying those. So it'll go to the correct fabric A or fabric B based on your Vsan ID. I keep saying Vsans, and now I finally have a slide on Vsans. So Vsans are virtual storage area networks, very similar to VLANs. So they're supported by Cisco MDS and Nexus only, not supported on non-Cisco switches. Non-Cisco switches, we just assume are Vsan 1. And honestly, with Cisco switches, we almost always see people just do Vsan 1. So if you're not using Vsans, everything defaults to 1. If you're using a third-party switch, we also default to 1. But if you're using Vsans, we can carve up one or more switches into virtual Vsans. So you may have an array plugged into a Vsan with some hosts on it, and then you may have a development Vsan with a different array and different hosts, and by default those two don't see each other. There's some things we can do to get around that, but that's another discussion. But normally it's used to carve up physical switches. So you may have a big director class switch with hundreds of ports, and you're like, man, I don't want all these on the same Vsan. We'll just carve them up and create these kind of miniature fabrics out of that. But a lot of times people will have a single Vsan on fabric A and a single Vsan on fabric B. And a lot of times it's, if it's third party or default Cisco, it's Vsan 1 on A and Vsan 1 on B, even though those two aren't cross connected. Remember that. I can't get to A fabric from B fabric normally because people don't cross connect them, even though they have the same Vsan number. When we configure virtual HBAs, we pin them to a fabric. So as I said a minute ago, it can only carry, a virtual HBA can only go up to a pinned uplink that carries the Vsan. That doesn't mean if I say this virtual HBA is Vsan 1, it can go fabric A or B. When I dictate that, and we'll see that in the service profile lesson, I say virtual HBA, Vsan 1, fabric A, or virtual HBA, Vsan 1, fabric B. You pick that when you create it. Hopefully that's not too confusing. It'll make more sense when you see it done in the service profile lesson. And then there's Fiber Channel over Ethernet. So FCOE is, I won't say it's new, but it's getting more mature by the day, and we're seeing more and more adoption. Simply put, FCOE is fiber channel encapsulated in at least 10 gig Ethernet. And it's more than just I'm going to slap fiber channel inside an IP packet, kind of like Iscsi is basically SCSI in an IP packet. There's other things that go along with FCOE. It's guaranteed to be lossless. So fiber channel is guaranteed lossless. We don't drop frames. If we do, we make sure we know where they went. We make sure in requests we resend. Same thing with FCOE. So there's things that we layer on top of Ethernet. It's not just stuffed in an IP packet or anything like that. It's done on a separate VLAN, separate headers and all that, separate configuration and syntax, and it's uses QoS and other bridging, what we call data center bridging technologies, to make this a lossless protocol. By default, it is used between the interconnects and the chassis. So we connect fiber channel into the interconnects, and then they're encapsulated in FCOE as they go down from the interconnects to the FEXs and then to the blades. If you're not using FCOE, but you're watching this for your own benefit or for training, you don't do FCOE. It's only used when we do fiber channel. It happens behind the scenes. Blades see fiber channel. They don't see FCOE. That stuff is stripped out and then they just see a fiber channel frame. No special configuration, standard OS tools. As an example, if I install VMware onto one of the blades with, say, a CNA card or one of the VICs, he doesn't see a bunch of fiber channel over Ethernet stuff. He just sees HBAs, and anyone who's managed VMware servers or Windows servers with HBAs and fiber channel will feel right at home. This is a question I get a lot. When I talk about UCS and I talk about the architecture and I talk about FCOE, and people go, whoa, 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 whoa. We don't do FCOE in the data center. We think it's too new. We're not so sure about that. But remember, we're not doing FCOE outside of the interconnects, outside the environment. Now, I say that with a bit, of a caveat. With some newer versions of UCSM and the protocol being more mature, we actually can plug FCOE capable storage arrays and things like that into the interconnects, but that's fairly new. We're not seeing wide adoption. By default, it's fiber channel, standard, good old-fashioned, been around forever and a day fiber channel into the interconnects. Those get encapsulated between the interconnects and the chassis. You don't even know it. You don't see it. The only real configuration we do is we have to tell it which VLAN to use for FCOE, and we'll talk about that here in a second. It's simple as this. You dedicate a VLAN to FCOE. So every Vsan you have, you give it a matching VLAN. This VLAN number needs to be unique. It can't overlap with one you're already using for Ethernet traffic. What we try to do is, do some sort of a formula. If we have Vsan 10, I'll do 110 or 1010 or something like that. But you just can't have VLAN 10 for data and VLAN 10 for fiber channel over Ethernet. You configure this in UCSM and you forget it ever existed, and just make sure you don't reuse it. I'll show you where we do this. When you build a new Vsan within UCSM, you assign it a VLAN number, and I'll show you how to do that. Other than that, you don't worry about it. That VLAN does not exist outside of UCS. Don't assign it somewhere else. Mark it off your list as being used, and just don't worry about it. And a little bit on virtual HBA. So I talked a bit about this before. Virtual HBAs provide fiber channel access to the blades, and some mezzanine cards offer additional functionality. So just like we did with Ethernet, M81KR and the VIC-1280, we can slice and dice up into virtual HBAs. The CNA cards are fixed configuration. Each port is one data port and one HBA port for fiber channel. So a dual port CNA mezzanine is two 10 gig network adapters and two 4 gig fiber channel adapters. 10 gig data cards like the Intel card offer no FC capability at all, so you're going to have to do something else with those. And here's one little thing that a lot of people don't, kind of overlook. In traditional fiber channel fabrics, I've got a rack mount server. I've got two HBAs in it. One HBA goes to fabric A, one HBA goes to fabric B. How do I fail stuff over between those two fabrics? Well, we have to use some other what we call multipathing driver. EMC offers PowerPath. Most modern OSs have some form of failover built or multipathing built in. It allows them to use both connections. We can give you access to a single LUN over both fabrics, so we can load balance across them. So PowerPath, Windows native multipathing, Linux native multipathing, VMware has some good native multipathing. EMC's PowerPath gives you really the best. It does all sorts of active load balancing and monitoring and all sorts of great stuff, but there's no automatic failover. If you remember when we talked a bit about Ethernet, I said, if we lose connectivity between effects and an interconnect, we can fail the VNICs over from one fabric to another. We don't do this with HBAs. So if we lose all connections from one FEX to the fabric interconnect A, those HBAs don't fail over to fabric and FEX B. It's sent up to the blades, to the OS, and says, hey, it's what's called all paths are down to fabric A. And then it's up to the multipathing in the OS to figure out what to do. So there's nothing else that you really need to configure. It's just going to be up to the OS. So it's just like any other traditional fiber channel configuration. VNICs can fail between fabrics. Virtual HBAs do not. And virtual HBAs, as I said earlier, are tied to a single Vsan membership. So when I create a virtual HBA, I give him membership to a single Vsan. He can't be in more than one. And we'll see that. If you need to have a blade belong to multiple Vsans, then you're really going to have to do like an M81K or a VIC and do multiple VHBAs, each belonging to one of the Vsans. Again, you've seen this table before. It's exactly the same as the one on the networking side. The device limits are the same. Just remember, if I use up a bunch of them for virtual HBAs, it pulls them out of my pool for virtual NICs. But just keep these in your head. I don't suggest you deploy 116 virtual HBAs unless you're doing something really crazy, but it's good to know. And again, the key thing here is it depends on the I/O module links, those FEX links. So that's it for kind of the lecture portion of this lesson, and now we're ready to jump to the lab. So we're going to do about everything. We're going to go to the lab. Probably, I think I'm going to go over to the Greensboro lab again, which is my physical lab, and just kind of walk you through some things because I have MDS switch there and everything to show you. We'll confirm in host mode. I'll show you how to create some Vsans, show you how to assign that FCOE VLAN. We'll enable some uplinks, create a port channel, show Vsan trunking, which is real simple, assign ports to a port channel, which is going to look scarily familiar to what you did on the networking side. And then I'm going to jump on the MDS switch and show you kind of how zoning is done, just as a kind of a quick primer so you can at least understand. It looks like a lot of stuff. I know that. It's going to show you everything you need to do for configuration. So with that, let's go ahead and jump onto the lab. Okay, here we are back over in the lab, and let's just start taking a look. So the first thing I want to show you is if you have the 6200 interconnects, just to reiterate one point, we come over to the Equipment tab, choose the interconnect, go to General, and we have Configure Unified Ports. And it's going to warn you that if you make changes to this, if you make changes to the ports in the main switch, it's going to reboot the main switch. If you make changes to the module, it's going to reboot the module. I'm not going to make any changes, so we're good to go. But again, the slider here dictates what is Ethernet and what is fiber channel. So we do this in two parts. We configure the main switch and we configure the modules separately. So the sliders here, that doesn't mean all these are fiber channel. It just means that all of the built-in ports are Ethernet. If we want to configure the module, we click Configure Expansion Ports, and it flips us over. The modules or the sliders here, right up here, which means to the left, these ports are all Ethernet, these ports are all fiber channel. So while they are unified, you have to make sure and configure the slider, and if you move it, it's going to reboot the module or it's going to reboot the whole interconnect. So I'll cancel. With the 6100, again, the FC ports are always in the expansion module, and they're dictated by which module, either the 8-port 4 gig, the 6-port 8 gig, or that combo with some 10 gig Ethernet and some fiber channel. So then if we want to look at, say, the mode, we can see right here that it is in end host mode, fiber channel mode, end host, just like Ethernet mode is. We go to Vsan Uplinks Manager. There we go. So if we click, again, just in case you missed that, on the interconnect, we can go to Vsan Uplinks Manager, and it will show us here that we are in mode end host. You click that button there, and it'll flip you over to the FC switching mode that I recommend that you don't use. We can look at several things here, such as our identity assignments. These are if we've assigned worldwide node names or port names to a blade out of our pool. So this right here is a pool we created, and we'll talk about this in the pools lesson. But we can see that this virtual HBA 1-A has been assigned these addresses. It's real easy to see. We can see our WWNN pools, PN pools, the configured Vsans we have already that I'll show you, and events in the finite state machine. But this is a quick and easy way to come in and get an overview of the fiber channel configuration like I showed you for the network. And we also have Uplinks Manager, which is just really showing you your uplink configuration, kind of the same, or that's the same place I just was. Storage Manager, which has some connectivity for fiber channel and storage FCOE. But most of what you'll be doing is in the SAN uplinks. Now, the first thing that we're going to do is create Vsans. To do Vsans, we go to the SAN tab. Now, if you're just doing, if you're not using fiber channel, you're not going to get a whole lot of use out of this tab. But for all things fiber channel, this is pretty much it. We have Fabric A and Fabric B. We can expand those and we'll see something very similar to what we saw in the Ethernet side. Port channels, uplinks, and instead of VLANs, we have Vsans. Now, do you remember how to make a VLAN? Because if you do, you already know how to make a Vsan. We can do it per fabric. So like, for example, here we have Vsan 11 on Fabric A and Vsan 12 on Fabric B, or we can have global Vsan numbers like we have here for number 1. But either way, you click this, or up here, we click the plus sign, create Vsan, and we give it a name, lab Vsan. Zoning, default zoning, we're going to leave that disabled. We don't want to enable default zoning. And then do you want it to be common, Fabric A, Fabric B, or again, just like we do with VLANs, both differently. But we can leave this as common. Then, for each Vsan number, we have to assign an FCOE VLAN, and I mentioned that. So let's say we're going to do these. Let's go ahead and do them differently. So for Fabric A, we're going to use VLAN 100, and Fabric B, we're going to use 101. Then we have to match up a matching FCOE VLAN. Now, nothing says you can't do this and this. We can absolutely match them if these are not used. So if VLAN 101 is not used anywhere else in the network, we can do that. If it is, you may want to do like 1010 and 1000 or something, but each Vsan has a matching FCOE VLAN. And again, you can't use these anywhere else. So it's a one-to-one mapping that needs to be unique. But once you do that, you'll hit OK, and successfully created, and we'll see it appear. Oh, there we are. 100 and 101. They are up here again because we did them separately. These are not global. You can click on either one of these and see the ID, the name, and the FCOE VLAN that we created. So very simple, not much to that. Next on the list is fiber channel uplinks and then port channels. We go back to the equipment tab, and the easy way to do this for me is to physically look at the switch here, figure out what port I want to use. You just do a right click and you just say you can enable it, and we're going to configure as uplink port. Uplink port is the default port type, so it's already selected. Here, I'll show you. If we go ahead and enable this port, there's no SFP plugged into it, so it's not going to love that. But we can right click and say I'm going to do you as an FC storage port. What is an FC storage port? Well, we haven't talked about that yet. We will after the lab. But it basically is what you would use to plug in an array straight to the switch. If you want to connect this up to another fiber channel switch, which is what you're probably going to do, you're going to configure this as uplink port. So you enable it and configure as uplink port. And off you'll go, and hopefully it's going to turn green much like this little guy is. So if we zoom in on him, we double click him, there's a couple of things you'll notice. First of all is that he's up and he's good. 4 gig connectivity is green, and let's see, he's an in proxy, which means he's using import ID or NPIV. This gives you his worldwide port name for the port and just some general information, licensing, things like that. We're already configured, and there we go. So it's really very simple to configure these ports. There's not a whole lot to it. Let's jump on over to the SAN tab real quick. Click SAN Cloud and Fabric A. And let's see, to enable Vsan trunking, we can enable that right here. So that's pretty simple. Just enable that, and again, all Vsans run over all trunk ports. We can scope down into the different Vsans, show the Vsan FCOE VLAN ID, gives you information about the transport, which is almost always going to be FC. Then it has your ports, your configurations, settings there, and finally port channels, which we haven't really talked about until now. What we're going to do here is we just assign the ports that we configure into a new port channel. So we've already got one port channel created. We usually name them after the Vsan. So this is port channel 11, matching Vsan 11, fabric A. And then it gives you the port. So we only have one connection up from the lab to the MDS, so it's only one per each. To create a new port channel, we do it just like we did on the Ethernet side. So we expand this out, we click here, we can either right click on this and create, or click the little plus sign. We give it an ID, so I'm going to do, I think I did 101, or yeah, 100. We can give it a name. Next, and then we figure out which ports that we want to use, and this would be one that we selected earlier. So you just pick and choose, and there's your connection. So I believe I did 13. We'll move that over. We can set the speed here if you want to, 1248. Normally auto is fine. If you have an issue, you can, force it, and then we click and finish. If you had 4 ports uplinked, you would add all 4, and there you go. So there's my new created port channel. And it does match my Vsan, so that was correct. Now, by default, it set the Vsan to 1. That's what I wanted to show you. It didn't really ask me what I wanted the Vsan to be. And don't worry about overall state indeterminate. It's hard to determine something when you're not really plugged into a switch. So that should have gone green if I'd plugged in. So you need to go in here and select your Vsan number. So for this, it would be Vsan 100. And I'll save changes, and that way it knows which Vsans that an uplink carries. Some other things that you can see, individual FC uplinks here. 13 is gone because we now have 13 on the port channel, but if we look at fabric B, we can still see that 13 exists here. Yep, that's what I want to show you as well. So after you enable your ports, you need to, even if you're not using port channels, you want to go in and set these to the correct Vsan. That's how you pin these to the correct Vsan so that it gets correctly pinned going up. Don't worry about that. Part of the lab configuration. But, oh, actually, I know what that is. I didn't set that up as 13 back on equipment. So if we go to equipment, go to B, I only did A. I got ahead of myself. So if we want to do this, so come to each of your ports, right click them, enable as an uplink port, or enable them if you need to. You can double click these ports, select the Vsan that you want to use, or if you're going to put them in a port channel, just go create the port channel and then assign the Vsan there, and everything in the port channel will carry those same Vsans. And again, if you want to enable Vsan trunking, we go to the overall fabric, general, enable FC uplink trunking. So that's pretty much all the steps you really do on the UCSM side. The only other thing you might want to do is probably a pin group. So pin groups are very much just like they were on the Ethernet side. So we come down here to pin groups. We'll do plus. We'll give it a name, lab pin group FC. And we can say here, and what's my target? Either port channels or interfaces. So I could say you're on this one. And for B, you are, actually I didn't configure anything, so we'll just say 13 and say OK. And that's it. So when I create service profiles later, I'll be able to say, okay, virtual HBA, you're assigned to this pin group, and it dictates which physical connections you're going to use. And that way I don't have it automatically pin in a round robin type fashion. I can force things. So, I mean, the FC configuration from this side is exceedingly simple. The only thing left is really going over to the MDSs. To do that, we'll jump to PuTTY. So, this is our MDS 9124. It used to be our Fabric A. So right now we're down to one switch, but it gives me the opportunity to show you Vsans. So the two Vsans I showed you are actually on one physical switch. We have Vsan 11 and Vsan 12. This lets us, split this switch into two separate switches for, logical functionality. Now I can still fail one physical switch and I'm completely offline from the storage side of the world, but it lets me kind of do this in the lab and show you how to do Vsans. Now, first, let's do show running config into grep npiv. So that's a command right there. It says feature npiv. This is a quick way to see if npiv mode was enabled on the switch. Now obviously it's enabled or else I wouldn't have functioning UCS environment, but if you want to see if it's enabled, you just do grep npiv and the command is feature npiv, or you can do show feature and right here. Notice NPV is disabled. That's what the UCS interconnects use. They use NPV. The switch uses NPIV. So again, if you try to enable NPV, it should throw up a big scary warning and you'll know real quick you're the wrong one. Then I want to show you zones. So first let me do show, let's just do show zone. Now, what I've got here is a couple of things. So let's see. Okay, here's one. This is a zone name, and you can name these things any way you want to. We use a simple naming standard, so CX4 SPA2. CX4 is the model of array. It's an EMC Clarion CX4. SPA is storage processor A. There's an SPA and an SPB on a Clarion. 2 is the front end port, so it's EMC CX4, storage processor A, front end port number 2. And then we're connecting to UCS ESX number 1. That's one of the hosts running in our UCS environment. Virtual HBA 1. So it's the first HBA. And when you do a zone, you have to dictate which Vsan it lives in. So we'll have some in Vsan 11 and some in Vsan 12. Below that, we have a pair of addresses. These are WWPNs. One of them is from the CX4, CX4SPA2. It matches that up. And the other one is from the UCS blade. Now remember, I said that in a pooling lesson, I'm going to show you how we're going to create logical pools of WWNNs and WWPNs. So I know what they are before we ever deploy our first blade. So I can pre-zone things if I want to. I already know what my Clarion's front-end ports are, and then I know what my HBA ports are going to be, so I can pre-zone if I want to. But what I want to show you is that this is what a zone looks like. It's usually 2 or more different WWPNs just put together, and that means this guy and this guy can communicate, and that's all there is to it. With MZS, you do a couple of things. We do what are called FC aliases. So if you want to see what these names are, show device alias Vsan 11 database. So what we've done is we've pre-configured this. So I'll scroll back up for just a second. These names off to the side, like UCS ESX1, VMHBA1, the reason it knows these names is because we created a database on the switch that says, hey, UCS ESX1, VMHBA1 is PWWN, that's Port Worldwide Name, or as you and I have been calling it, WWPN, this. So it's just a simple database. Now, I can do zones up here without ever using names. But one day I'm going to come in and go, okay, what's 2000025B511A9F? I don't remember. I'm going to have to go look that up in a spreadsheet. It's just a way to easily see, get human readable names matching up against these big hex numbers. So we create those. When you do this, you usually create device aliases like this, or also known as an FC alias. They're slightly different. Device aliases can exist in multiple Vsans. FC aliases don't, but don't worry about that. But we create this kind of name to WWPN mapping. Then we create zone sets, which are nothing but pairings of things that are allowed to talk. And then we create what's called a zone set. A zone set takes all the zones that you've created, all these pairings, and puts them in one big group, because this zone set is named prod Vsan 11, and he lives on Vsan 11, and we have a zone set. And the reasoning for a zone set is that for whatever reason you may have different groups of zones, and what you do is you activate the zone set. So I create my FC aliases or device aliases, then I create my zones, which are just groupings of things I'm allowed to communicate. Then I take all my different zones and put them into a zone set. And then when I'm ready to actually say, okay, this is the things I want the switch to actually let communicate, you do what's called you activate the zone set. So to show you that real quick, I'm going to zoom way to the bottom of this configuration. Zone set activate. Name prod Vsan 12, which is the sister one to prod Vsan 11 on Vsan 12. So we actually have two zone sets active, one on Vsan 11 and one on 12. And so that's the different steps. So it's really a three-step process. You create your zones, you put zones into a zone set, and then you activate the zone set. And here, on a Vsan, on Vsan 11, you can only have one zone set active at a time. On Vsan 12, only one at a time. So it allows you to make changes, get it like you want it, and then say, okay, I'm going to activate it now. But while you're mucking around making changes, you're not causing disruption. It's only once you're happy with it, you say activate, and it's like hitting the apply button. If you use Fabric Manager, this is all done via GUI. You may find it easier. I, however, do not. But again, that's kind of the purpose. The last thing I want to show you is a command called show floggy. Floggy is Fabric Login Database. Let me expand this out a little bit, make it a little easier to read for you. What it shows us is for each FC port, literally each port on the switch. So this switch has 8 ports in use, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, and 1, 8. There's nothing plugged into 1, 2 that's working right now. But it shows you which initiators are logged in. So FC11, I see 3 different initiators. Well, why do you think I see 3 different initiators? Well, simply it's because I'm using NPIV mode. So each port has a bunch of initiators behind it, and if we look here, we have our port name, WWPN, and the node name, the WWNN. So if you're ever confused, like, okay, I don't get it. You know, I brought this blade up, I see what its port name is, but it's not talking to storage. Do a show floggy database and see if your initiator's popping up here. If it's not coming up here, you're not having a zoning issue. It's not an issue where the two devices aren't able to talk due to a zoning problem or even a LUN masking problem. If he's not logging into storage, it's probably something on UCS side, something like you've configured a new Vsan, but there's no uplink that can carry it, something like that. So you need to figure that out and then figure out why you're not logging into the fabric. And that's usually one of the biggest issues we see, something like that. Once you get Fibre Channel login, then you can start looking at zoning issues and LUN masking. But first, make sure you're seeing Fibre Channel login. So that was a big lab. Hopefully that was very helpful. Showed you an end-to-end Fibre Channel configuration. So with that, let's jump back over to the slide deck. So that's everything we did. We logged in and went to the Uplinks Manager and confirmed end host mode. Then I showed you that you can create Vsans. You can create different Vsans per fabric or a Vsan that's global. Like if you use Vsan 1 on both sides, we can just have a Vsan 1 global. Very much like unique VLANs or global VLANs. Then when you create a VLAN or a Vsan, I showed you how you have to map it to a Fibre Channel over Ethernet VLAN. Since FCOE rides across the Ethernet fabrics, it needs a dedicated VLAN. So you do a one-to-one mapping of Vsans to VLANs. Then we went into the interconnect and we figured out which ports we're going to plug into the Fibre Channel switches, and we enabled those as uplink ports. We took those uplink ports and we put them into a port channel. Again, if you don't use port channels, when you enable your uplink port, you need to put it in a specific Vsan. If you put them into a port channel, then you set the Vsan on the port channel itself. So it's slightly different depending on which one you do. I showed you to enable Vsan trunking. You go into the SAN tab, pick the Fabric A or Fabric B, and select it there on the left. We assigned ports to the port channel, which is, we did that when we created the port channel. And then I showed you an example of zoning. So zoning is basically a 3 or, depending on how you look at it, a 4-step process. 4 if you do your FC alias or device aliases first, kind of give them a friendly name. Then we put them in zones. So we put like our target and our initiator in a zone. Then we take all those zones that we've created and put them into a zone set. And then when we're happy with the zone set, it's all good, we activate the zone set. So that's your 4 steps. Now, things like FC alias and device alias are MDS specific. To do brocade and stuff like that's going to have different names. But in the end, that's pretty much the standard methodology for doing Fibre Channel zoning. That is what you do for implementing storage on UCS. You know, if you're doing Fibre Channel, create your Vsans, configure your uplink ports, make sure you map your Vsans correctly, create your FCOE VLANs, plug everything in, and if you have a problem, start looking on the MDS side and seeing if there's a mismatch or something like that. Make sure that NPIV is enabled on the switch, and just go through the process and be very methodical. But that is pretty much your going through fiber channel configuration. And then the last thing that I want to talk about are other storage ports. In UCS M14, Cisco added 3 new port types. There's appliance, FC storage, and FCOE storage. Appliance is very simple. I've got an NFS server or an Iscsi server, and I'm going to dedicate it to UCS. So if I go in there, and here's the thing, appliance port is a network port. So remember how we did the slider if you have a 6200? You would configure an appliance port on the left of the slider. It's a network port. I put it in the storage lesson because it connects to NFS or Iscsi. But to be honest, you can use it for other things other than NFS and Iscsi. Cisco may look at you funny and be like, I don't know. But the long and short of it is it's a standard Ethernet connected port. It just doesn't do some things. Like it doesn't get included in pinning for uplinks. It's not used for broadcast listening or propagation, some things like that. It's a limited use port. The idea is you physically plugged something into it. It's not plugged into the rest of the network. So it's a network port. You're going to right click on that port on the left of the slider or anywhere on any of the 10 gig ports on a 6100 and choose appliance port. And then you're going to direct connect your NFS or Iscsi appliance into that. Fiber channel storage port or direct connected FC storage. Again, there's no zoning in that. There's some caveats there that we talked about, but you can direct connect. And then the last one is a newer type of port for fiber channel over Ethernet. So if you have an array that supports FCOE, NetApp does it, EMC does it, you can direct connect that in as well. Again, there's no zoning and there's some caveats around that, so it's not something that's widely used. But as these expand, we'll see it used more and more. So, appliance port simply allows for direct Ethernet connectivity, not a regular uplink. FC storage is for direct connected FC arrays, but they don't perform fabric services such as zoning. And the FC storage port is similar to the FC port, but it's for direct connected FCOE. So not something that we see in use a lot of today, though we are deploying with the appliance ports on a fairly regular basis, but everything else is very limited. And that is it for this big lesson. So hope that you got everything out of it and it prepared you for your deployment and or the exam. We started with Cisco UCS and storage connectivity. So general things about what type of storage. So you can do NFS, Iscsi, Fiber Channel, FCOE, whatever. But really for boot protocols, you've got Iscsi and Fiber Channel. We talked about the fact that if you want to use service profiles, if I want to get this stateless environment where I can pick up a service profile, move it to a different blade, and shift server install from one blade to another, we have to do a boot from SAN type arrangement with that. And the only other the other gotcha there is if you're not doing Fiber Channel now or you don't want to do Iscsi boot, the new version of VMware vSphere 5 does Pixie boot from network, which I call boot from nothing. So that's an option as well. If you're an all VMware shop, you can just do boot from nothing using auto deploy and get a similar functionality. Walked you through hopefully a good primer on Fiber Channel. Idea being, I want you to be able to talk to the storage team or a vendor and understand the connectivity and what's required for connecting UCS to the Fiber Channel fabric. Remember, interconnects use NPV. Your switch needs to be an NPIV, and the rest is fairly simple. 4 gig Fiber Channel, 8 gig Fiber Channel, just depends on their connectivity. Plug everything up, and it's very simple. Connecting SAN ports, I showed you logging in. If you have a 6200, we adjust the slider, but we enable a port and put it as an uplink storage port, very much like an uplink network port. When you enable an uplink port, you're just going to assign a Vsan to it. If you're using port channels, you assign the Vsan to the port channel. And Vsans are very much like VLANs. They allow us to virtually segment or logically segment a single physical fabric into multiple fabrics. A quick run over FCOE, Fiber Channel over Ethernet. By default, if you're using Fiber Channel connectivity, FCOE is used between the interconnects down to the chassis and the FEXs. It doesn't have to be deployed elsewhere in your data center. So, that's again a question I get a lot, but it's really just used internally. Like VNICs, virtual host bus adapters are just those ports on a blade, and if you have a VIC card, we can slice and dice and come up with a whole bunch of different ones. But keep in mind that a single virtual HBA belongs to a single Vsan on a single fabric. So a VHBA may be in Vsan 10 on fabric A, and it also may be a virtual HBA on Vsan 10 but on fabric B. You can't be in multiple Vsans or both fabrics. And we don't do hardware failover of virtual HBAs. It's up to the operating system, just like it always has been for multipathing capability. And finally, the 3 new ports for other storage ports: appliance, FC storage, and FCOE. These are for direct connection to the interconnects without going through other switches or networks. It's becoming more popular, but the only one we see a vast use for right now are the appliance ports for Iscsi and NFS. So again, that's kind of the other side of the coin of the network configuration. If you get through your implementation and you got the network good, and now you've got storage, and you're almost there. Really, now it gets really, really cool, because we're going to talk about pools, and we're going to talk about service profiles, and you're going to see the stateless nature, and we're going to build upon all the work that you've done up to this point. So with that, I hope you're really excited about it, and I'll see you on the next lesson.